Lesson 19.2, Task 2. All right, so this is the conclusion of the task that we started in the last video. So we are on part C. So it says, how can you determine the percent of female mountain lions in the study that weighed more than 54 kilograms? What is the percent? Okay, so if you remember from the last video, we went ahead, or I went ahead and drew these normal distribution curves based on the data given. So the top one here is the male, and the second one is female. All right, so we're looking at the female curve, and what we're going to do is say, how can you determine the percent of female mountain lions in the study that weighs more than 54 kilograms? So here's 54 kilograms. So we want to know more than 54 kilograms. So all of this area over here. So all of this area, we need to know what is this percent. All right, so let's go back and look at our percentages. We know that 48 is our mean. And there's 34% between the mean and one standard deviation. So there's 34% we know right here. So this is 34%. And we know that the next one is 13.5. And we know the next one is 2.35. And the last one is 0.15. So all we have to do is add those percentages up. So what we're looking at is above 54 kilograms. And if you take your calculator, you can quickly add those percentages up. So we've got 13.5 plus 2.35 plus 0.15. And that gives us 16. All right, so it says recognize that 54 kilograms falls one standard deviation above the mean, and add the percent of the right of that label. So all of these to the right, okay? Add those up on the graph of the normal distribution to get the percent of 16. So what we did was we added everything to the right of one standard deviation from the mean to get that. All right, what is another method for determining the percent of female mountain lions weighing more than 54 kilograms? Well, another way to look at it is if you know that the mean is in the middle. All right, that means 50% falls above the curve, or the mean, and 50% falls below the curve. So you could do 50 minus the part you know that's not included, and that also gives you 16. So right here where it says double the percent, no. Recognize that 50% of the weight are greater than the mean, yes. And that 34 of the weights are between the mean and 54, so subtract 34 from 50. So basically you're still taking this and adding it up, but instead of doing that, you're doing 50% of the data is on the right side of the mean, subtract the part you know that's not part of that, and that gives you your answer as well. All right, so that's all for task 2. If you have any questions, let me know. Lesson 19.2. I'm going to do a couple extra examples to kind of get you started and make sure you understand the normal distribution curve. All right, a battery manufacturing company has begun production of a new battery model. During testing, the company determined that the length of time the battery can power a laptop is normally distributed, with a mean of 8.2 hours and a standard deviation of 1.4 hours. Use the empirical rule to find the percent of laptop batteries that will last the following length of time. All right, so anytime we see normal distribution curve, the very first thing we need to do is draw our normal distribution curve. And let me try that again. Does not look like a normal distribution curve. Let's see. Should be kind of symmetrical. All right, so we know that the mean goes in the middle. The mean is 8.2 hours. And we know that we're going to find 1, 2, 3 standard deviations in each direction because that's the percentages that we know. So we're going to do 8.2. All right, let's do 8.2 plus our standard deviation is 1.4. 9.6, we're going to do plus 1.4 again, 11, and plus 1.4 again, and that's going to be 12.4. So we're going to have 9.6, 11, and 12.4. All right, on the other side, we're going to calculate that by subtracting our standard deviation. So we're going to start with the mean again, 8.2, and we're going to minus 1.4, minus 1.4, and minus 1.4. All right, so we're going to have 6.8, 5.4, and 4. All right, so it's easy to draw the normal distribution curve knowing that you are given a mean and a standard deviation. Remember, the mean always goes in the middle, and then you got the mean plus 1 standard deviation, the mean plus 2 standard deviations, the mean plus 3 standard deviations. To the left, you've got the mean minus 1 standard deviation, minus 2 standard deviations, and the mean minus 3 standard deviations. All right. Let's find out. Use the empirical rule to find the percent of laptops that will last the following lengths between 5.4 and 11. So we can see that 5.4 and 11 both are 2 standard deviations from the mean. So that means we go 68, 95, and 99.7. So this is 1 standard deviation, this is 2 standard deviations, this is 3. Because I go 2 standard deviations, I automatically know this is 95%. All right, the next question says, no more than 6.8 hours. So no more means everything in this direction, everything less than 6.8. We know that 8.2 is our mean. We know that 1 standard deviation is 68%. So if I take half of 68, this gives me 34% here. And I want everything to the left of that. So the mean is always in the middle. So I can quickly do 50 minus the 34. And that gives me 16%. So number 12, no more than 6.8 hours, would be 16%. All right, so what is between 8.2 and 12.4? All right, so 8.2 and 12.4, that's our mean. And 12.4, which is our 3rd standard deviation. So it's almost 50%, but remember there's that 0.15 that accounts for those outliers out there. So this is going to be 50 minus the 0.15. So if you do 50% minus 0.15, that's going to be 49.85%. All right, once you learn these percentages, especially these 3 right here, These are fairly simple to do. All right, so the last one says at least 5.4. And so at least 5.4 means everything above 5.4. All right, so at least 5.4, so everything in this direction. So we know that like these middle ones are 95, and that means there's 2.5% here. So we've got to take off the 2.5%. So I know that, again, everything in 2 standard deviations is 95%, and I'm just playing with numbers here. So if I have 95% here, that means I have 2.5 here and 2.5 here. All right, so I want at least 5.4, everything above this. So it would be 95 plus this 2.5. This 2.5 is below that line, so it's not included. So this would be 97.5%. All right, that's your normal distribution curve, and a couple examples to kind of help you get started. If you have any questions, please let me know.